we will discuss the next unit, that is the normality. We have done the molarity and now we are discussing the normality. Normality represented by capital N. What is the definition? See, the number of gram, listen, in the molarity or molality, it was number of the gram moles. Now in this case, it is number of the gram equivalent of solute dissolved in, that is the same 1 liter of solution. Again, what you are seeing, that in the molarity it was moles, in the normality it is equivalent, and the remaining definition is same. What is the definition? Number of the gram equivalent of solute dissolved in the 1 liter of the solution. So the formula is capital N equal to number of, we can say, gram equivalent of solute upon volume of solution. See, this formula and molarity formula is exactly same. The difference is, instead of the mole we have written the equivalent. So the normality becomes number of the gram equivalent of solute divided by volume of solution. Remember, it should be in the liter. Now see, how can we find the number of the gram equivalent of solute? Number of equivalent of solute, formula is same, mass of solute divided by, in the case of the moles we divide by the molecular mass, in the case of the equivalent we divide by the equivalent mass of solute. So this is the formula number 1 of the normality. Number of the equivalent of, formula number 2, number of equivalent of solid is equals to mass of solid upon equivalent mass of the solid. Number 2, and this is number 1. So if we can put the value here, then normality becomes, remember, WB, I have told you earlier in the last class, WB is the weight of the solute in gram divided by EB. Now what is EB? It is the equivalent mass of the solute multiplied by volume of the solution. It should be in the liter. So this is the formula number 3. See, if volume is not given in the liter, again the concept, normality is equals to WB upon EB into volume. If it is in the ml, multiply by 1000. This is the formula number 4. So 1, 2, 3, 4. These are the formulas, and observe this, that in the formula of the molarity and in the formula of the normality, almost things are same. The change is, in the molarity here I would write MB, molecular mass of the solute. In the case of the normality, I am writing EB, equivalent mass of the solute. Now the question comes, how can we find the equivalent mass? Let's see. If we want to find out the equivalent mass, then what we have to do, the formula of the equivalent mass is equals to molecular mass if molecule is given, or atomic mass if atom is given, or formula mass if ion is given, divided by either valency. If acid is given, I can take basicity. What is basicity? Number of H plus ion generated by any acid. See, if base is given, then what I will do? In case of the base, I will write acidity. What is acidity? Number of OH minus ions generated. If ion is given, then I would write the charge. See, if we see some examples, first, acids. In the case of acids, the most common is HCl, HNO3, acetic acid. These are the few acids where they are going to give only one H plus ion. So normality is equals to molarity upon 1. Or sorry, my fault. E it's also right. And you can say equivalent mass is equals to molecular mass upon 1. Now see, it's the main formula. Equivalent mass is equals to molecular mass upon 1. Now if we plan for H2SO4 or H3PO3, they are going to generate 2H plus ion. So equivalent mass is equals to molecular mass divided by 2. If we go for H3PO4, it will generate 3H plus ion. So equivalent mass is equals to molecular mass divided by 3. So in the case of the acid, we can go this as one more important acid. It's the boric acid. See, if the boric acid is given, formula is H3BO3. But remember students, in the case of boric acid, its basicity is 1. E is equals to equivalent mass equals to molecular mass upon 1. It is an important topic. Reason behind, because generally if we observe the structure of the boric acid, then it is the structure of the boric acid BOH, OH and OH. Now generally it is in the case of the oxy acids. What are oxy acids? The compound which have hydrogen, oxygen and the non-metal. It is also an oxy acid. Yes. It is also an oxy acid. Yes. It is also oxy acid. Yes. It is also. Yes. It is also. What is the oxy acid? A compound having hydrogen, oxygen and the non-metal. And in the case of the oxy acid, the number of H plus ion replaceable is equals to those hydrogen which are bonded to oxygen. If we see, if we go for H2SO4, see, H2SO4 is there. This is the structure of H2SO4. Now in this case, we know that the both hydrogen are bonded to oxygen. That's why we are saying its basicity is 2. If we see S3PO3, this is the structure of S3PO3, P double bond O, OH, OH and H. Now in this case, what we are seeing in the S3PO3, 2 hydrogen are bonded to oxygen and the 1 hydrogen is bonded to phosphorus. Therefore, its basicity is considered to be 2. This hydrogen is not liberated as H plus ion. Why? Because it is not bonded to oxygen. So if you observe, again we take the example of S3PO4, P double bond O, OH, OH and OH. Now in this case what we are observing, 3 hydrogen, all of them are bonded to oxygen. That's the reason why S3PO4 I have written its basicity to be 3. Now in this case, although in the boric acid hydrogen is bonded to the oxygen, but even then boric acid does not lose its own H plus ion. Why? Because it has got the 3D giant structure in which the hydrogen